Finally, I have built my very simple 3D printer enclosure. Not the most beautiful one, but at least it's practical enough to do its job. I need to keep my eyes on temperature since the heat has a limited area to dissipate. I've already added vent and exhaust fan, but not enough to give me the trust to leave it unattended. Since I have no enough time to spend on this project, I decided to rig a simple solution to give me a chance to take an action whenever a temperature goes out of normal. There is a Raspberry Pi and ESP32CAM lying around me, never put in a practical use. With them and DHT11 sensor LED strip, our system will give us temperature, humidity, camera stream, and light. As an added bonus, no single line of code will be written here. With the help of open source software like Home Assistant and Esp Home, the work should be already done. Home Assistant and Esp Home are free and open source systems. We choose to use them to make our life much easier and to avoid writing our code from scratch. Home Assistant used as a central system for home automation and IoT technologies. And Esp Home is a firmware we will install inside our ESP32CAM to make it communicate with Home Assistant. In this tutorial, we will only deal with the configuration files, which we are going to copy from their official websites. There is a whole lot of lessons out there explaining Home Assistant and Esp Home in much detail. But I wanted this lesson to be self-contained with the least amount of external resources. Home Assistant documentation offers multiple methods for installation process. Install it as a standalone operating system is the easiest method and also recommended by the documentation itself. To complete installation, we need to download Balena HR program from its official website. We will use it to copy Home Assistant image files to microSD card. From Home Assistant releases page on GitHub, copy the link of current version related to Raspberry Pi 4. Paste it inside Balena HR. Attach a microSD card to the computer and choose it as a target. Click flash, wait until it finishes, and that's pretty much it. The setup process is done. It's hard to find anything easier than this. Now it's time to run the Raspberry Pi with the new operating system. Plug the microSD card back to Raspberry Pi, connect the Ethernet cable, connect the power cable, give it a while until boot process complete. It's now ready to be accessed remotely. Before going any further, it's hard to continue without mentioning the Wi-Fi. If you just like me have problem with cable lying all over around the place, then definitely you'll need this. There is possibility to run Home Assistant with Wi-Fi instead of Ethernet cable. For this you only need a USB flash drive formatted as FAT32 and labeled as config with all capital letters. In the root folders, create a folder named network. Inside that folder, create a text file with the name My Network. Open this file with any text editor. Paste Wi-Fi configuration inside it, which you will find in the description. Change My SSD to the name of your network and change My secret key with the password of your network. Plug the flash drive to one of the USB port on Raspberry Pi, run the Pi, and if the configuration done correctly, it will connect to the network. It's now okay to unplug the flash drive, it's not needed anymore. After finishing, install Home Assistant. Open web browser from your laptop or PC and try one of the following host names. If still none of them work, then we need to find the IP address associated with the Raspberry Pi. We can't do that by logging to our Wi-Fi router if we have access to it, or using one of the IP scanners programs such as Angry IP. After downloading and installing Angry IP, scan your local network for all IP addresses. Copy the IP address associated with the Raspberry Pi and paste it into your web browser. In the first run, we need to provide some essential information such as username, password, unit system, and location. In the next step, Home Assistant will explore home network to find any smart devices that are already connected. If found any, it will ask you if you would like to add it to Home Assistant platform. After we have done installing Home Assistant, it's time to install Esp Home. But before we start, we need to know that Esp Home comes in two parts. One part will work as a firmware, which is the part we will install inside our ESP32CAM. The other part will work as a platform that is used to receive the signal from the firmware. To install the Esp Home platform, we will integrate it as an add-on in Home Assistant. And it is as easy as going to Add-on Store, search for Esp Home, then click Install. Wait until installation complete, then click Start. And that's it. Definitely that was easy. It's time to take a turn to install Esp Home firmware in ESP32CAM. If you ever worked with ESP32 or ESP8266 that has a USB port on the board, then you will notice there is no one available on this board. Because of that, we need an external programmer. We could use one of the widely available programmers such as CH340 or CP2102. But since there is a good chance that you already have an Arduino Uno lying around, we will use it as a programmer. By using some jumper cables, we will make some connection between Arduino and ESP32CAM. You need to connect 5-volt pins in both boards together. Do the same thing with ground pins. Connect TX0 on Arduino to U0T on ESP32CAM, and connect RX0 on Arduino to U0R on ESP32CAM. To activate programming mode in ESP32CAM, you need to connect GPI0 to ground, and connect reset to ground in Arduino board to make it work as a programmer. The connection part is done. Let's jump back to Esp Home interface. Create a configuration file and name it whatever you'd like to name it. In my case, I will give it the name 3DP. In the next screen, enter your Wi-Fi credential by typing access point name and its password, then click Next. From board selection screen, leave it as ESP32, click Close. A new entry appears which has a long red line, indicating that no connection between Esp Home platform and ESP32CAM. To convert this line to green, we need to burn the firmware to ESP32CAM board. Plug a USB cable between Arduino and Raspberry Pi, then click Install. Several choices show up for uploading method. Since Arduino connected directly to Raspberry Pi, we will choose Plug into the computer running Esp Home dashboard. Choose the port that is connected to Arduino, and the installation process will start. In case firmware installation process failed, you may want to restart the upload process and press Reset button in ESP32CAM immediately. When done uploading, be sure to disconnect the GPIO0 pin from ground in ESP32CAM board. Press Reset button. Give it a while and you will see the red line in Esp Home dashboard converted into a line. And if you take a closer look at your Home Assistant interface, you will see a notification icon, which means a new device is discovered. To integrate the newly added device to Home Assistant, you will find a new discovered device with the name 3DP. Click Configure, then Submit. Choose the area if you'd like, then click Finish. From now on, Arduino is no longer needed because any update can be pushed to ESP32CAM remotely using Wi-Fi only, and we can disconnect Arduino from the setup. We only need to provide a 5-volt power to ESP32CAM from any source, or just keep the Arduino as a power source only, by keep 5-volt and ground pins connected and unplug everything else. We have finished installing the basic systems. Time to add some functionality to our setup. One of the most powerful things about Esp Home, its comprehensive library of sensors. Just a little search in their website and you definitely will find what you want, at least if it is one of the popular sensors. For DHT11, temperature and humidity sensor instruction and configuration already available at their website. But before that, we need to do some connection between DHT11 sensor and ESP32CAM by simply connect the rightmost pin of the sensor to ground pin in ESP32CAM and the leftmost pin of the sensor to 5-volt pin, and connect data pin, which is the second pin from the left, to the pin labeled IO13 in ESP32CAM. And we should not forget the pull-up resistor with the value 4.7k ohm between data and power pins. Leave the remaining pin unconnected. In the Esp Home official website, we will search for DHT11. Copy the example's configuration code. In Esp Home platform, click Edit. Paste the code to the bottom of the configuration. Change the pin D2 to match the pin that DHT11 connected to. In our case, it's GPIO13. Click Save, then Install. From Installation Method menu, choose Wirelessly. The installation process will start. Just wait till it finishes. After done, let's now add our newly created sensor to Home Assistant interface. Select Overview, click the 3-dot icon, then Edit Dashboard, Add Card, go to By Entity tab. From the menu, choose the 2 entries related to DHT11 sensor, which is living room temperature and living room humidity. Click Continue. Then add to Lovelace UI. After that, exit the dashboard editing mode. You will see a new card displaying current temperature and humidity, and update it every 10 seconds. Adding LED strip is almost similar to the process we follow when adding DHT11. We have an LED strip of a kind, WS2812B. As shown in the diagram, we make a connection between ESP32 cam and LED strip. We just connect 5V to 5V, ground to ground data line to pin GPIO12 in ESP32 cam. In Esp Home website, search for WS2812B. From the search result, select Fast LED Light. Copy the configuration sample, then paste it at the bottom of the device configuration entry. The only thing we need to change is the pin number, which we set here to be GPIO12. As an necessary step, we prefer to change name to match our LED strip kind, Fast LED WS2812B Light. Click Save, then Install, and also choose wirelessly to do the installation through Wi-Fi. To add the LED strip control card to Home Assistant, we do the same thing again. From Overview, Edit Dashboard, Add Card. By Entity, select our newly created entry. Then continue, Add to Lovelace UI, Done. From this control card, you can turn LED on and off, change the brightness and change the color. And also there is a plenty of light effect available at Esp Home website under the light component. Just choose the effect you like, paste it into the configuration and reprogram the board. Then you can choose the effect from control card. Since the camera already integrated into ESP32 board itself, no connection are needed. Just search for the camera on Esp Home website, copy the configuration for AI Thinker model, which is the model that we have. Paste it to the bottom of the configuration file, save and install. Then add the camera to the Home Assistant Lovelace using the same previous method. From Overview, Edit Dashboard, Add Card. By Entity, select My Camera, then continue, Add to Lovelace UI. Done. We only need the camera whenever we want to investigate the 3D printer, so the rest of the time it will remain idle. It only will be activated whenever we look to our Home Assistant and click on its thumbnail. ESP32 cam has onboard flash LED. It will give a considerable amount of light whenever extra light is needed. Be sure to use it as briefly as possible, since it will radiate an extra amount of heat which the board could not withstand, and it will affect its performance. Just add the following YAML configuration entry at the bottom of your configuration file, which you will find in the description below. And you guessed it, add it to Home Assistant Lovelace, only find the entry with the name Flash Switch. To this point, the project should be announced as finished, but it is going to be an ugly project if we kept it as it is without any aesthetic finish. So a 3D printed enclosure is a must to combine all components in one case. So I have made a simple 3D printed enclosure, designed to be a friction fit, and all components will just snap in its places. And also it comes with two kinds of flavors, one with a hole for cooling fan and one without. With an articulated arm, the positioning is now easier. Attach it to a weighted base to make it stable. Now the job is done. You will find the 3D model and any needed resources in the description below. Please, if you found this project helpful for you, consider subscribe and like and share. Thank you very much.